urban areas, water resource, and other sector, but very dynamic and very vast applications now used in coastal studies. सो कोस्टल स्टडीज़ में क्या है कि डिफरेंट लैंडफॉर्म जो है वो थोड़ा टेरेस्ट्रियल लैंडफॉर्म से अलग होता है, तो इसलिए ज़्यादातर कोस्टल एरिया में ज़्यादा मॉनिटरिंग की ज़रूरत है और डिफरेंट बायोडाइवर्सिटी ज़्यादा है, इसलिए उसका एस्पेक्ट बहुत ज़्यादा है, वनरेबिलिटी जोन भी है. सो the different features like wetland and mangrove forest, एक्वाकल्चर ponds, ये सब कोस्टल एरियाज में ज़्यादा दिखाई देता है. स्पेशली मैंग्रोव फॉरेस्ट इज ओनली फॉर कोस्टल एरियाज. सो बिफोर गोइंग टू दिस, एक्चुअली क्या है कि देर इज ए CRZ कोस्टल रेगुलेशन जोन नोटिफिकेशन इज देयर 2018-19. So according to this, the CRZ coastal regulation zone, the coastal area is divided into four category, that is CRZ 1A, 1B, CRZ 2, CRZ 3A, 3B, 4A, 4B. तो इसमें क्या है कि जितना भी वाटर बॉडीज पार्ट है समुंदर के पास 500 मीटर के अंदर, तो वो CRZ जोन में जाता है, फ्रॉम HTL हाई टाइड लाइन टू 500 मीटर टुवर्ड्स लैंड पार्ट. और जो लैंड पार्ट से समुंदर की तरफ वो CRZ 4, मतलब जितना वाटर बॉडीज इन द क्रीक और इन द रिवर ऑल आर इन CRZ 4. Then CRZ 1B, that is one is further divided into 1A and 1B. 1B is the beach area, तो इंटरटाइडल जोन, हाई टाइड टू लो टाइड जोन, तो जिसको हम बीच बोलते हैं, दैट इज कैटेगरीज इज CRZ 1B. देन CRZ 1A इज इको सेंसिटिव जोन, जिसमें हमारा मैंग्रोव आ जाता है, सॉल्ट मार्स, मॉड फ्लैट, देन टर्टल नेस्टिंग ग्राउंड, bird nesting ground, then forest areas, and uh, coral reefs. Likewise, जितने भी इको सेंसिटिव जोन है उसको हमने CRZ 1A में कैटेगराइज कर दिया. तो उसमें क्या है कि किसी भी प्रोजेक्ट अगर कोस्टल एरिया में चल रहा है तो इट इज़ नॉट given a license to this project in the CRZ 1A and 1B area. 4 एरिया तो वाटर बॉडी से वो तो नहीं होगा. देन CRZ 3 जो है फ्रॉम CRZ 1B टुवर्ड्स 500 किलोमीटर, HTL टू 500 किलोमीटर, सो इसमें परमिसेबल है. तो उसमें से भी डिफरेंट कैटेगरीज आता है, CRZ 3B और 3A. तो 3A जनरली पॉपुलेशन डेंसिटी ज़्यादा है, अगर 2161 स्क्वायर किलोमीटर से एज पर 2011 सेंसस, देन इट इज़ CRZ 3A. और 3B जो है तो रूरल एरिया जो है उसको 3B, एंड CRZ 2 जो है वो अर्बन एरिया को CRZ 2. सपोज इन मुंबई दैट इज इन CRZ 2, चेन्नई CRZ 2, फ्रॉम कोस्ट टू 500 मीटर. So below, above 500 meter, it is not under CRZ. So these are the category. तो कोस्टल एरिया में रेगुलेशन, तो कोस्टल एरिया को प्रोटेक्शन करने के लिए तो कोस्टल रेगुलेशन जोन नोटिफिकेशन के हिसाब से अभी काम चल रहा है. So what is the coastal zone? The coastal zone is a transitional area between land and sea, and it is bend rather than a line. The width of the bend varies from place to place. Some area जो tidal intertidal zone है 1 kilometer 2 kilometer in the northern coast of the east and west coast in Gujarat and Odisha. So intertidal zone is very large, and some areas intertidal zone is very low in near the Goa or in Mangalore beach or in the Chennai. So depend upon the landform, the coastal area is changes, and zone in the coastal area generally occupies less than portion of the Earth's land, but 40% of the uh, peoples are residing in these areas because it's a very uh, resource oriented areas. That's why the high population density and occupies 80% of the surface of the globe. 60% of the world population lives in the coastal areas. Two-thirds of the major cities in the world, one of the major city like Mumbai, metro city like Chennai, Kolkata. So these are the all highly population densities and due to the coastal presence of the coastal area. And the population density is 6 times higher than non-coastal areas. That's the one of the problem in the coastal area. And 90% of the fish which are used in the market are from the coastal areas. Then 70 to 80% of the global sink of suspended river loads are in the coast, and 90% of the global sedimentary minerals, just like manganese nodules. So why it is important to study the coastal area? Because it is a very dynamic process because the river meets in the coastal areas. So a lot of landforms are formed and it changes dynamically every years, and the different resource and different tourism activities, irrigations, forestry, my sand quarry, urban areas are present, beaches are present, then oil extractions like in Mumbai, and sand extraction, industry, flood area zone, and fishing activities are largely dominating in the coastal areas. And so that's why the coastal area is very much important for the studies in for the prospect of the remote sensing and GIS. Then why the coastal area is important due to the fruit, vegetable, agriculture, fisheries, oil, sand, salt, shipping, oil refineries, beach, swimming, sail, ecotourism, pipeline, harbor. So these are the features. And the coastal zone is major highlights like high population density and high degree of urbanizations, fragile and complex ecosystem and habitats. It is fragile because most of the time some beaches are eroded dynamically due to different cyclone activities, and due to some tsunami activities, a lot of landforms are degraded, and due to the flood effect, a lot of uh, habitats are lost. So high density of economic activity like fisheries and other industrial activities are there, like different agricultural activities, and conflict and competition for resource, land, marine, and water, and then over exploitation of natural resource like mining activities, and over exploitation in the fishery activities. And pollution is major concern in the coastal areas because of lot of pollutants are present in the river, and this river connect to the sea. That's why the accumulation of all the pollutions pollutants are present in the near shore areas. So degradation of natural environments so effect due to the pollutions and other anthropogenic activities, and loss of biodiversity, natural habitat, increased erosion, and loss of protections. And that's why the coastal zone management involve planning and organization of development process, control activity of coastal area aiming at the sustainable use of natural resource of the coastal zone. The information required for the management of coastal zone is very diverse because of a series of aspects. That's why the different period of remote sensing technology like satellite image for monitoring is very much important. So a lot of organizations are taking part for the protection of the coast like hydrology department, soil water conservation, environmental expertise, forestry, agroeconomy, physical planning, and different other organizations. So, what is the characteristic of Indian coast? India has a long coastline of about 7,500 kilometers, including its island and territories. And east coast, there is large fan-shaped deltas, which comprises of mangroves, which is present in Sundarban, Bhitarkanika. Now the Bhitarkanika is a national park. It's around saline lake like Chilika in the Odisha, then Pulicat in the Andhra Pradesh, then Gulf of Mannar in Tamil Nadu. So west coast like narrow coastal strips, estuaries, creeks. So a lot of creeks are there in the Gujarat coast, and backwaters is very dominant in the Gujarat coast. Sandy beaches are there near the Maharashtra coast and Goa coast and Mangalore coast. So Gujarat, Saurashtra, Kutch, and estuaries Narmada, Tapi, Mahi. Several ports are also present. Coral reefs generally present in the Andaman Nicobar, then in the Maharashtra and in some part of the Gujarat and some of the Gulf of Mannar, but it is not present in the West Bengal coast or in Odisha coast. So, Andaman and Nicobar Island has a dense forest and meandering saline creeks are there, coral reefs are there. Lakshadweep also coral reefs. The Lakshadweep itself is a coral reef island is there. So there are 40 marine and coastal protected areas in the coastal area. So issue in the coastal zone management of Indian coast is the high and the first priority is that the population density. Then there is the high population density like Kolkata, Chennai, and Mumbai. Then mangroves, coral reefs, ecosystem degradations are nowadays very prominent in Odisha coast, also in Andhra coast and Tamil Nadu. So municipal sewerage, waste water disposal is one of the issue. Then industrial effluents, solid waste disposals, natural disasters like cyclone, tsunami, then coastal flooding, and impact of aquaculture. So nowadays, for the better economy, the shrimp culture is very dominant in the coastal areas. That's the one of the issue that it is hard. May increase the salinity of the land part, so the paddy culture is not possible in that land in future. And coastal erosion, some part of the area is high erosion and some part is a high accretion. Then impact of port. So due to the port activities, the pollution is increases and the natural habitats of the different species are also decreases, like turtle nesting ground, then horseshoe crab, and other marine animals has largely impacted due to this in ports and other industries. Then coastal mining, sand mining, or other heavy minerals are also extracted using this coastal area. Then coastal construction like seawall or other activities for the tourism purpose and ingress of seawater. So due to the extraction of lot of uh, activities, the seawater intrusion is one of the major activity because gradually the seawater uh, combine with the groundwater near the coast areas. So the fresh water is contaminated with the saline water. Then it is one of the issue for the drinking purpose. Then impact of power plant, impact of tourism also. So this is one of the site which is the aquaculture ponds are there. so which impact the mangrove. These the red patches are all mangrove forest. So due to the progression of this aquacultures, the mangrove gradually decreases. So previously the mangroves are in all these regions. So the anthropogenic activities largely impact the natural resources and natural forest areas near the coast. So, which type of characteristics of the remote sensing that is helpful for the analysis of the coastal areas? So, generally, we use blue, green, red, infrared bands of list 3, list 4 images and other satellite images also like Sentinel or Landsat data. उसमें क्या होता है कि रेड लाइट attenuates rapidly in water, so does not penetrate deeper than 5 meters. So the red light penetrate in the water up to 5 meter of depth, and blue light penetrate up to 15 meter of depth in clear water when up to 30 meter. So green light penetrate as far as 15 meter clear water around coral reefs. So that's why these red, blue, green lights mm, get the information about the clear water or pollutant waters or the water qualities. Then near infrared penetrates to maximum depth of zero point 0.5 meters. So generally it penetrate नहीं कर पाता. That's why it is absorbed by the water bodies in the near infrared region. That's why in the near infrared bands, the water in a single near infrared band, the water looks like the black, totally black. That's due to the absorption of water bodies in this spectrum. So a lot of activities like a lot of studies using the remote sensing technologies are going on like mangrove, coral reefs, salt pans, aquaculture, wetland, other coastal inland resources. These are all monitoring using different IRS, list 3, list 4 satellite image. Then fisheries activities, that is forecasting and monitoring. It is monitoring using NOAA satellite and IRS P4 satellite. Then mineral and energy explorations, like it is in the research and development stage, that can be used by the hyperspectral remote sensing technology. And coastal geomorphology and shoreline change, these are also using different high resolution satellites like cartosat in images. Then sea surface temperature, wind, wave, other water vapor contents, upwelling and eddies. These are all studies with the IRSP4. Then coastal regulation zone, which is now recently studies, that is using the different satellite images like LIS 3, LIS 4, and suspended sediment concentration is generally used by the LIS 4, LIS 3 images. Then oil slicks, generally using some microwave remote sensing and other remote sensing satellites. So chlorophyll concentrations also using iris satellites. So how they are integrated, the tropical cyclones give the strong winds, storm surge, sea level rise, and heavy rainfall in the coastal areas, which damages the different structures, and due to the flooding, loss of lives, loss of other agricultural activities, and destruction of different crops. So these are all interrelated. So due to the tropical cyclone, a lot of effects are there in the land of the coastal area. Then the remote sensing technology like this satellite image give the information about the cyclone and how this affected. So this is the super cyclone on the Odisha coast in 30 October 1999. So this is the sandy beach and different habitations. and the river and intertidal zone. Then another aspect is how the fishing activities and fish availabilities are monitoring. So previously, there's a compass or previous experience, the color, bubbles breaking on the surface, muddy and oily waters, which shows the presence of the fish in the seawater and reflection in the night and smells. These are the factors which are generally used by the fishermen to identify the more fish-prone areas in the sea. So nowadays the PFZ, that is a potential fishing zones, are identified using remote sensing technology. So generally, this the factor that generally the fish are more largely present is that the light, presence of light, then chlorophyll, then nutrient, wind, surface current, oxygen, dissolved oxygen, that is salinity, temperature. So the temperature information we can get from the remote sensing satellite image, that is thermal image. Then wind information, wind information also we can get from the satellite image. Chlorophyll and light, these are also, and surface current. We can get all this information using remote sensing technology. After that, we can get some field observations, and we can divided all this zone. So which is more potential fishing zone, and which is less potential fishing zone. So the satellite remote sensing also very powerful tool employed in the wise use of fisheries resource, including potential fishing zone, that is PFZ. The first use of satellite remote sensing in fishery development is 1971 in the US. So how the potential fishing zone areas are generated. So due to this, NOAA a very high resolution satellite image, then IRS-P4 ocean color monitoring image, then data extractions, then sea surface temperature and computations, then geometric correction, then after interpretation of fishery forecast, the PFZ chart are generated. So this is one of the map of the potential fishing zone. So in these different colors are of different temperatures and some potential fishing zones. So generally fish are uh, present in the cooler environment. So this is the temperature scale. So in the blue region, 20 to 25 degrees Celsius, these are the blue region. So these are the potential fishing area, potential fish zone areas. So we can get more fish in these areas as compared to the other areas. Yes, it is a high temperature areas like 33, 32 degree temperature. So after getting all this information, it is communicated to the all the fishermen and other fisher businessmen, so that they can get to go to these areas using different GPS points, then get all the then the fishing activities are going on. So this is now currently going on for the PFZ. So this is the result, that is the green graphs are the result of the potential physics zone activity using remote sensing, and the red are the other local experience activities or other technologies. So after shown that the PFZ using remote sensing technology, there is a high growth of the production of the fishes uh, in these areas. So it is very much successful using the remote sensing technology. That's why nowadays it is widely acceptable, and currently also these are going on with the fishery departments, and Then this is one of the map that shows that in the Odisha coast there is a erosion area. There is in the red area, and accretion in the green areas, and some salt water intrusion. So some salt water, that is the red dots are there. So in the freshwater zone, the salt water mix in the ground level, so that it is very much vulnerable to these areas. You cannot use this water for the drinking purpose. Then for calculating the coastal vulnerabilities, lot of parameters are there. So we can get coastal vulnerabilities using these parameters. So out of this, we can take 5 to 4 parameters for different applications and different coastal vulnerability studies. Which means geomorphology is one of the factor that is most widely accepted for the coastal vulnerability parameter. Then seaward slope from high water line, then beach slope, historical soil change, sea level rise, wave height, tidal level, soil practice, soil size, flora, fauna, that is the different forest areas and other biological activities, coastal infrastructure, that is New land cover, coastal population density, tsunami magnitudes, presence of artificial coastal erosion, cyclone intensity, average coastal land elevations, cultural value of the coastal properties. So these are the parameters which can be used for analysis of coastal vulnerabilities. How this area is more vulnerable based on this parameter. So we can study all these parameters. So for the rocky cliff coast in the first picture, that is very low vulnerability ranking because it cannot be eroded easily. Then medium cliff, it is less slow. That's why it is low vulnerability ranking 2. Then Indian coast low vulnerability. Then low cliff. So cliff area is just as the presence of rocks, so it is moderately vulnerable. Then glacial drift. This is the upward movement of the ice in the mountain. Then glacial drifts are there. Then the moderate vulnerable ranking. Then alluvial plains, moderate vulnerability. So it can be more vulnerable if the flooding is affected. Then cobble beach, high vulnerable ranking. Then estuary is generally considered as one of the high vulnerability ranking, as most of the flood areas are there, and it is estuary is the zone between the sea and the mouth of the river. So it is a joining of the river and the sea water. That's why, due to the high tide, the water enters into the land part, and due to the flooding, the waters cannot go to this sea area, and that's why it's spread over the both the banks. So it's uh, one of the vulnerable zone. Then lagoon also very much vulnerable due to the connection to the sea and water bodies inland. Then barrier beaches, these are the areas where sometimes it is inundated by the water in the high tide line, so it is highly vulnerable. Then sand beach, it is also very vulnerable because tidal high tide line can submerge all these areas during full moon days or in the cyclone effect time. Then salt marsh, which is an intertidal zone, so it can be submerged in the high tide time, and it is uh, water is taken away in the low tide line. So it is very high vulnerable. So any constructions activities are prohibited in these areas. Then mud flood, it is a intertidal zone areas. It is also very high vulnerable because of the presence of the seawater in all the times. And deltas are also very much vulnerable because most of the deltas are presence of intertidal zone. It's a mangrove forest. So mangrove is vulnerable, highly vulnerable areas. So this is the mangrove forest, which is presence in the saline waters. Then coral reefs is generally in the very low depth of the sea, and the presence is near the coast. That's why it is very high vulnerable. So these are the coastal different studies and different activities are there, and a lot of applications are using this technology, like different satellites are gathering informations. And one thing I want to provide you one note is there for land use land cover manual is there. So this is one of the land use land cover manual. Just a minute. So this is the different land use land cover which are classified as a ISRO, which is provided by ISRO. So you can refer this classification techniques, how these are classified using different satellite images, using list 3, list 4 images. So with their definitions, what is the built up land, what is the urban land, what is core urban, what is peri-urban. So core urban is generally the highly populated area, and peri-urban is uh, it is connected to the core urban. So how to demarcate all these features in the satellite image? So it is the remote sensing interpretation skills are there. So you can get more information and knowledge by using this guide, and this is I will provide you today. Uh, these are the mixed settlements. This is the village. How to demarcate the polygon. Then this is the mixed settlements. How to create the polygon using the different features. Then this is the hamlet and dispersed village. So you can be classified to hamlet village, and this is the village. Then mining areas. It looks like this. Some of the water bodies are there, and some quarries are there. Quarry are there. So this is the mining areas, and the false color satellite image. Yeah, this is the industry, and this is the polygon of the industry. Then the cropland, then the aquacultures, which is nearby the coastal areas, then agricultural plantations, then there is crop forest, then the mangrove areas, which is present in the Gujarat or in Odisha also. So wastelands look like this. Then scrub lands, open scrub, dense scrub, sandy areas. These are the sandy areas in the Rajasthan area. Then river. So how to demarcate all these features? These are the guidelines. You can refer this for your improvement of the image interpretation skill. And these are the shifting cultivations. So you can give this as a shifting cultivations. Then river, all the water bodies. Then road, Kocha Pakka road. Then soil type and soil mapping units, you can look for it. So this is the soil, which is given with field photograph in the Cartosat image, Morse image. This is one of the soil, laterite soil. So it's look like this, and It is look like this type of tone in the satellite image. This is the black soil, so it's look like this in the satellite image. So before identifying this, you have some idea about the this localized area or some basic information. So generally, black soils are not present in all the states. So it is dominant in the Madhya Pradesh, some part of the Gujarat, and some of the Chhattisgarh areas, and the western western Odisha also it is present. So these are the dominant black soil area. So we can get all the information, and after that we can create the polygon. Then these are the alluvial soils. So these are the plain, and this is the desert soil. So this is the flow chart of some silent picture of methodology for vegetation mapping or any land use land cover, recharge structure, groundwater prospect layers. So you can refer this. Then this is a different mining areas and some minerals, how these are look like in different satellites like the granite, dolerite, limestone, quartzite, shale. It is a coastal area of the Odisha. So this is the coastal plain. It's look like this. Then this is the hilly terrain areas. This look like this. So it is a alluvial plain of younger, and it is a alluvial plain of older alluvial plain. So it is a Himalayan region. So these are all about this manual of the land use land cover classification techniques. You can refer this. I just sent this manual to our WhatsApp
Yes,
group.
sir. Received.
So you can refer this for your classifications of land use land cover, and all the definitions are all the basic informations are provided using all this including the all the features and all the this write-ups. Okay, so you get it in the our WhatsApp group.
Yes, sir. Get it, sir.
Okay, so just download it and just refer for your image interpretations or land use land cover classifications for basic ideas are there. Okay, then I will conclude this session. So any queries are there, then you can ask. Hello.
नो सर, बस सर आप स्लाइड शेयर कर दीजिएगा आज वाली सर, थोड़ा सा रिवाइज कर लेंगे बैठ के।
ओके ओके, मैं सेंड कर देता हूँ।
ठीक, बाकी सर ठीक है, सारा कोस्टल की है, ठीक है।